Bringing up our next speaker. His son and I have shared a similar career path, and we've lived in actually some of the same spots. He co-founded an early blockchain identity management platform, Cyber Deadbolt, which was acquired in 2017. Paul has now founded BLOCKid to provide digital identity management, risk management, and security for sensitive information and smart contracts. Ladies and gentlemen, please give a warm round of applause and welcome to Mr. Paul Heirendt.
Good morning. So I swear Alex and I had not met before this morning, but I could not have had a better setup for my presentation. So this talk is called The Blockchain Train. Is it time to get on board? I was hiking in the sequoias and I heard this train whistle. And so I kept hiking towards it, and then I was running towards it because it kept getting louder. And I thought, wouldn't it be cool for my talk on blockchain and blockchain train to get video of that train coming down the track? I waited and I waited and I waited. Finally, I hiked to the station and the train was there. And I asked somebody there, I said, so I was standing there, but it never came. He goes, no, that's the coast track. You would have been standing there for a week before a train came along. And I thought, okay, this is even better metaphor for blockchain. There's a lot of hype about blockchain, but a lot of people are going to be standing on the track waiting for the train to come. And sometimes that train's never going to get there because it's been overhyped. And other times the train will get there, but it's not quite there yet. So the whole goal of this talk is to separate the reality from the hype. So you're not standing there waiting for the coast train that won't come for some time. So question in the audience, who wound their watch this morning? Anybody? Usually there's one, and I say, because you have one of these, right? I wouldn't mind winding that watch because it's a Rolex and it's worth winding, right? Did you change it for the time zone? Any of you that traveled? You changed for the time zone, right? I've had 12 time zone changes in the last 3 weeks. I haven't touched my watch. That got me once though, because I had an airplane mode. So in New York City, I called and said, we're running late. And they said, no, it's an hour from now. It's like, oh crap, I didn't take my phone out of airplane mode. So the network updates the watch and it becomes invisible to us. So any sufficient technology is indistinguishable from magic. And if anything right now about blockchain, it's like a magician and seeing everything about how the trick works. And then actually most of the time it doesn't work. So that's where we are with blockchain. But when we get to the point of invisible technologies, that's when it improves human productivity. And Eric's statement about the reduction in time, that's a perfect example of what this technology can do, but only when it's invisible. In other words, it works like air. It's there like air. So one of my heroes is Buckminster Fuller. He said, you never change things by fighting the existing reality. To change something, build a new model that makes the existing models obsolete. And that's part of the reason why there's friction around blockchain, because we're not building on the old model, the old centralized trust model. So there's two technologies I want to talk about and unpack for you so we're all on the same page. One is blockchain and the other is distributed ledger technology. So what's the value of the blockchain? Why are we even talking about it? Why does it have so much hype? Really, it's a system of traceable, trustable, and transparent record. So it's a system of record that meets those 3 T's. Those 3 T's are really essential in finance, but they're also essential in just about anything else that has value. Unfortunately, we're in the hype cycle. Gartner says we've kind of come over the hump. I don't believe that at all. I think we're on the left somewhere way low. And there's going to be a big, big disillusionment phase. But hopefully we can shorten that part of the hype cycle. But if you look at the news, that's news coverage. It's just spiking. So it's in the news. But we have no consensus, right? Sorry, that's a blockchain joke. Nobody laughed. We have no consensus because even in trade finance, there's 5 consortia. I ran a consortium in medical publishing, and it was bad enough running one consortium with a bunch of competitors. I can't even imagine 5 different consortia with some members in some and not in others. I don't know what they're doing, but it can't be anything meaningful for the industry. So what is blockchain? So I like to break it down. I like to think in terms of 3s. So the thing that everybody hears about is cryptocurrency, and you're hearing about some blockchain applications. The next level down is actually the blockchain protocols, and we're going to unpack this. And the base layer is this idea of distributed ledger technology, right? So what's distributed ledger technology? Let's start there. So this system of record that we've had forever is, whether that's a monetary transaction, a supply chain transaction, whatever it is, the idea is we all participate and systems participate, and it all gets to a central authority, right? So that's centralized. And the whole idea of blockchain is decentralized. Distribute that record, so you have a system of record, so that proof is provable across many areas. So if somebody presents something that's not true, you can validate or invalidate it in that case, because there's a system of record out there. And I'll unpack this technically a little bit. But I want to start with, I mentor for 3 different high school entrepreneur programs, and I thought this example was good for high school kids. I'm finding out they understood this, but a lot of business people don't get it even when I do this. So go buy a piece of ledger paper and a Sharpie and record something. And it's funny because Alex said chair. We're going to record a chair. So I'm an accountant for a major corporation. I've got a subsidiary. Guy in the marketing department buys a chair. I record that in the ledger, right? I make a description of the chair. I put down the serial number, the cost, and who it's assigned to. Now, if it gets moved to somebody else, I don't go back and edit that, right? That's in the ledger. I put a new entry in the ledger that says transfer the chair from marketing to sales, right? So that's the idea of an immutable ledger. That's why I use the Sharpie. It can't be erased. So you record that using the Sharpie, and then you distribute it to a bunch of your friends, right? So now everybody has a copy of that record. Everybody else is making records, copying it to everybody. So now you have this big mess of stacks of ledger paper, right? So there's a problem here. It's great, a great idea. None of them are changeable, but how do you make sense of it? So you have to have timing, order, you have to validate the entries, and you have to have some form of security, right? That's where blockchain comes in. So before we talk about blockchain, there's a lot of confusion in the difference between hash functions and encryption. Both are cryptography, but they're very different. And actually, the confusing thing is in blockchain, you can employ both. But for the blockchain itself, primarily it's hash functions. So a hash function takes some data and through an algorithm reduces that to a value. And that string can be short or long depending on which hash algorithm you use. So that's, you take data and you reduce it to that. If you change any of those bits, in other words, the zeros and ones, just change one of those, that hash value is going to be different. So it's one way. It's like taking an orange and making orange juice. You can't then make an orange again out of the orange juice, right? It's one way. Try putting that back in the bottle, right? Encryption is 2-way. So you can take an original set of data, you can encrypt it, in other words, scramble it, using a public key. And then a person that's authorized can use their private key and recreate that original. So hash function is what you use to validate blocks on the blockchain, but you can put the data in that block in encrypted form. Make sense? So what is blockchain? Really, really simple. You start with a genesis block, which is some amount of data. You then hash that block. So you take that data and you create a hash. So that hash, we have a service called Email to Sign, and somebody gets a PDF and says the digital digest of the document. We say digital digest these days because when we said hash, people thought we were talking either breakfast or drugs. It's neither of those, and it's not a hashtag, right? It's this digital digest. So it creates that value, and then you have another block of data. You take that hash, the original hash from the first block, the Genesis block, you store that along with the data and create a hash of that combination. So that is the chain, right? You have blocks of data. The chain is that continuous hashing of the data going forward. So you might say that's interesting, but you still have this, remember the ledgers all spread out. So basically you merrily along and all of a sudden there's two candidates. How do you make that decision? A lot of people think that at this point there's a decision between the two blocks. That's not really how it works. Both of those blocks are temporarily confirmed, but it's when the next block is confirmed, that's using a consensus algorithm, that's when the fork goes away. So the vector of the chain is determined not by where there's two blocks, but when that next block is determined. So it's just a very efficient way to keep the record going forward. That's all well and good, but remember, they're one-way hashes. What if I change the data in the Genesis block? This works if you change it in any other block, but it's most dramatic if you see. If I do that, that hash is going to be different. What happens? That chain is broken. And the next chain is broken because all of that data rolls forward in hashes and you've changed a bit, so the whole chain. So what happens is the chains fall apart and there's no such thing as other blocks, right, as a part of the record. And actually, that record can now be invalidated because it's not part of a chain, right? It's no longer associated because the hash is different. So that's a really high-level, simple explanation, but I hope that helps you understand how blockchain works. The key point is there has to be some consensus about that vector of the chain, which is the legitimate part, right? So proof of work is one of those. It's where you expend a lot of computing power to solve a math problem. So one of the co-founders of one of the companies I'm involved in is in Iceland right now visiting a high-performance computing center. They have them there because they don't need cooling and they get geothermal electricity. So it's interesting. But it requires a lot of work, a lot of energy, and the problem is the one with the most computing power is always going to win. And I'll show you exactly the fatal flaw with that. So everybody said, okay, well, what if people have an investment in the network, you would think they want it to be pure and go forward. So let's do proof of stake. So that is the nodes, also called miners, they compete for the privilege of confirming that next block by voting and based on their stake in that chain. So the problem is, this guy loses every time, this guy loses every time, and the rich get richer. So it's kind of a failed idea. It's based on the idea that everybody will work correctly. And when I do this talk as a workshop, I have people do this little game. And when I did it, I saw at one of the meetings, I knew two developers, really smart guys, and I thought, those guys are gonna win this little game I have. So they won in like 3 seconds. And then somebody else, I said, sucks for you. Somebody else raised their hand and said, sucks for you. So whether it's computing power or it's stake, there's this fundamental flaw of fairness, right? Is that a fatal flaw? Potentially, and we'll see maybe why. So this is a chart of the megawatts used in mining currencies. So notice China is 4 times what we do in the US, and Georgia, Russia in other words, is 2 times. So all of a sudden you can see, and I'll tell you why that's the case. Because of Bitcoin pooling. So China, and this is a very recent stat, December 23rd to January 10th of this year. So China actually pooled their mining resources and were responsible for 78.9% of the mining. That's a little scary. But the proof of stake is even scarier. So this is a kind of a convoluted chart, and it may be hard to read, but the bottom line is 4.11% of addressees own 96.53% of Bitcoin, and the rest of us only own 3.4%. So that gives you a little better idea. So the problem with proof of stake is it only works if everybody keeps voting, but if you know you're going to lose every time, why would you vote? Same things happened with computing power. When the price of Bitcoin came down, we have a mining group in St. Louis, all the guys that mine. We have 70 people in the group, only 10 are still mining because the price went down to where they can't afford to do it. And 4 of those they have free internet and free power at a co-working place. I think the co-working place is going to figure that out, but it's hard not to make money when everything's free, right? Other than the hardware. So we're seeing lots of new protocols because everybody's a little nervous. So across the top are some of the new protocols, the leading ones, and then those are all features. The problem is, I said we're at the beginning of that hype cycle. If you notice, the gear icon means it's in the works. Worse yet, the X's, which I don't know if you can see from there, but the X's they don't intend to support that, and privacy is one of those. So in my mind, everyone that doesn't support privacy, that's a real problem for trust. And that comes to governance. So consensus algorithms are how you confirm, but that only works if you have good laws and rules that govern that network and how that network works. So the idea is governance is beyond just the rules. It's also who gets to set the rules, who gets to change the rules, how they're enforced, right? So here's the importance of governance. This was my life when I was with a Fortune 120 company. Then, gentlemen, it's the consensus of this meeting that we say nothing, do nothing, and hope it blows over before our next meeting. That's a consensus, but it's bad governance, right? They were called to the meeting to do something. So there are lots of new kinds of consensus protocols. The two I like the best, proof of elapsed time. We do a lot of identity work. You can't use proof of elapsed time. I go to log in, I can't wait 3 days, right? For the login to confirm. I won't even go to that site. And proof of burn. The whole idea there is for you to vote, you have to burn some of your cryptocurrency. I'm not signing up for that. I don't have that much cryptocurrency. Remember, I'm in the 3%. So. But there are some whole new ideas being set forth. One of those you should look into is called Hashgraph. So go on YouTube and look for Hashgraph. And it's a very interesting new protocol based on some old computer science, but some really interesting math that uses graph theory. And I won't go into graph theory here because that could be a whole day. But using graph theory as the consensus, so it's a form of virtual voting. Super fast, super secure, and scalable, and very stable. So we are at the edge of some really interesting use cases for blockchain. And this is the best graphic that I've seen that really lays out, I had to redraw it for the black background because I wanted to be consistent. It lays out, there's 4 basic areas for use cases: smart contracts, digital currency, record keeping, and securities. I think you could probably categorize those, and some things could move, but I worked with it as I was redrawing it and thought, this guy put a lot of time into that. So one of the interesting things that is the blockchain train actually leaving the station is the Dubai project. Dubai has made a commitment that 100% of their government is going to be blockchain enabled. And that is far reaching. Smart city programs, not just paperwork, right? So 100% by 2020. Now, if you have more money than Michael Jackson, maybe you can pull that off, and that's the case with Dubai, right? Very interesting project. Most of the participants to date have spent several $1 million just to get a seat at the table. But this could be a very interesting use case combining IoT, government services, payments, government identity. It could be really, really interesting. And it's a great laboratory because they have the money to spend and the rest of us couldn't afford to do this science experiment. So there's issues with blockchain. I heard a lot of people say, oh, well, our corporation decided on Hyperledger and IBM's going to help us do that. I said, and you're going to use it for supply chain? Yeah. How many transactions do you do a day? Oh, probably 2,000 or 3,000. I said, no, you don't understand your supply chain application. You probably do 50 to 100,000 a day. And if your revenues are like in the 10 to $100 million range, you'll be bankrupt with less than a year, some companies in a month. Because it's not really the appropriate use of that blockchain, the expense, not just the transaction but expense, but all the expense. The other problem is you're going to have to use multiple blockchains for different kinds of transactions. And right now there is no interoperability. It just doesn't exist. Everybody's taking a different approach, there are different kinds of ideas around the business model, so that's a problem. You can't really build a blockchain-enabled enterprise without having all pieces being supported and being interoperable. Digital identity is a core function required for trust. I've been in the digital identity space since 1998 and nobody solved it. The other big issue is people say, well, we're using the hash for that block as the record locator. My legacy company, we moved into the AWS cloud in 2005, and we made our system stateless, which means every step in every process has an identity and it's passed to the next step. We started seeing hash collisions when we got to 1 million transactions. So I told you the data gets reduced and it creates that. That doesn't mean that a different set of data couldn't do that. So you can't rely on that hash for the address. So we had to build a system we call the guaranteed globally unique ID. And that's the core idea of BLOCKid. So also you have no security without authentication and rights management. How do you enforce the governance without actually holding people accountable? Right? And the technologies and protocols are advancing. So what we do is we apply machine learning, artificial intelligence, and distributed ledger technology to create what we're calling an intelligence layer for the blockchain. So what does that mean? That means we've separated in 3 layers. Blockchain protocols are 1 layer. And for some of our customers who are government customers, others that are large corporations that don't want their records visible to anybody else, we're creating blockchain systems for them. But also, we're creating intelligence around the performance, security, scalability of the other chains that are available. And we're working with partners on that. So we become this layer with APIs out to the blockchain protocols, but also APIs that developers can build applications not having to understand blockchain. Like my watch, right? Don't have to set it. Same idea here. So we're building 2 demo apps, the 2 green blocks, identity, and when we say identity, we don't just mean people, we mean everything. People, digital goods, transactions, all the way around. And all the other applications, supply chain, we've got a large DoD supply chain that's going to use this, another commercial supply chain that's an integrated consumer goods company. Healthcare application, tracking equipment and staff. E-commerce application, tracking ads. Did the person see the ad? Did they purchase as a result of that? And then intelligent assistance applications, where identity is really critical. You don't want somebody creating a schedule for you with people that don't really exist or that are fraudulent. And then rights management. So having your identity doesn't do you much good if you can't do something with it. So the rights management is a key piece that we're building. And the 2 applications that are being built on our rights management. One is media rights management. So for the beat producers that we work with, they can create a beat and they can get a BLOCKid embedded in that beat. So now somebody can't later say, you stole my beat. Excuse me? Mine's in the blockchain, has this date and timestamp in my BLOCKid. Then when somebody downloads that, they can purchase it. So let's say it's $100 for commercial, $1 for personal. So my son puts a beat up there and I go, or a track, and I say, well, that'd be cool, but I'm gonna pay him $1, right? I'm just gonna listen to it because he's my son. So I download it. Then I decide, I have this YouTube video, and I go, you know, Jesse's song would sound good on that. So I use it. I'll get a $99 bill because I use it commercially. So not only is the creator's BLOCKid and the BLOCKid for the track, there's a BLOCKid created for the rights that I purchased, and that's auditable. So the BLOCKid for the track and the BLOCKid for me as a purchaser, and what our smart contract is embedded actually in the audio or the audio of the video. So it can be traced by bots. So the artist doesn't have to do anything, but when somebody uses it commercially, they get paid. I had a problem with YouTube. I put one of my own songs that I wrote on a YouTube video, and I got a content strike. It's like, really? I get it for ones I licensed. You don't know I licensed it. But I created this. I could show you the logic file with all the tracks. And they said, well, we have no way to track that. It's like, well, you will soon. So really interesting applications, but you ask yourself, that's great, but no industry moves forward without standards, right? So luckily, IEEE has formed what's called the Blockchain Engineering Council, BEC. And so they're taking a system of systems model. They're not specifying technology, they're saying these are the kind of systems. And part of what they're focusing on is this interoperability problem, right? Exactly as I described. Now they put the apps below and an open API up to the interoperability layer, but it's exactly what we've been building both at Deadbolt and now at BLOCKid. So a couple of the examples that they published. This is the Open Blockchain Energy Framework. So energy has been an area where people say, oh, well, it'd be great because I'll be able to, if I have solar panels, then somebody else can buy energy for me. Except no infrastructure exists for that, right? They can give you credit if you generate power and your meter goes backwards, but they can't. There's no system to monetize that or to even track that for me. So that's what, one of the things that they've built is this framework for energy, especially not individuals, but more at the industrial level, but prosumer, so residential, if you have your own microgrid, that kind of stuff. So they're building standards. They also, for IoT, they have a reference architecture. And it's very interesting because it's very similar to a couple of the companies that are out there saying you need an end-to-end solution for IoT. Just throwing devices out there and putting them on a network is a bad idea. We had big denial of service attacks because people's refrigerators were being used to ping certain websites because they were just sensors out there that had internet capability. And I or anybody else with medium programming skills can take those and make them do things. So this idea that there needs to be a reference architecture to make that safe and reliable. So if you want to look more, look at, send an email to hello@blockchain-eng.org, and they can send you a lot of information, which is great. So the blockchain train has left the station. Question is it going where you need it to go? So you need to ask yourself some very basic questions. What's the scale of your project, right? A lot of people are talking about blockchain applications and AI, and they're really business logic and accounting systems, right? There's no need to put that on the blockchain, right? You really need a project at scale to see that value coming back as he said, changing, what was it, days, multiple days into minutes, right? So you also need to decide can this be in a public blockchain or should it be in a private blockchain? What are your performance requirements? Is there a token or no? So you notice this whole talk has been cryptocurrency free until now. But so tokens that are used for utility are interesting, but if they really are utility tokens, they probably don't have a lot of speculative value. So it's kind of an interesting thing that you need to look at. And do you even need tokens? So as Eric said, let's start with the value. So this is a 10-point value test. And if you want the slide deck, it's available. Just send me an email on the next slide. I put my email address. But these 10 things are really critical elements to look at. And you're going to find a lot missing in a lot of the pronounced protocols right now. They're still working on some of these things. And the difference between auditability and accountability, auditability is great, but accountability down to the actor or the system, that's really lacking in most of the protocols. So what that means is everybody thinks, oh, I put it in the blockchain, it's completely trusted. Blockchain has nothing to do with the validity of the content in those blocks, right? So you can put anything in that block. It could be falsified information, it could be fraudulent, it could be a registered rare good that's not actually a registered rare good, right? So very important things to look at. And if you want a copy, send an email to Paul@blockid.cloud.